Hi, good morning. In today's video, I'm going to solve this problem. Let z be the set of integers. Determine all functions f from z to z such that for all integers a and b, f of 2a plus 2f of b equal to f of f a plus b. This is International Math Olympiad 2019, the problem number 1. Pause the video if you would like to give a try to this problem. When you worry, come back to see how to solve this problem. Okay, let's start now. So, this is not too hard, but it's very tricky, okay? So, as you see here, you have a composition of these two functions, f of a plus b. So the first thing we should do here, we are going to think how to simplify this composition from the expression. Okay, this is the most important thing we should do. So to do that, let's give special values for a, for the number a as a integer. Okay, so for this equation we have f of 2a plus 2f of b equal to f of a plus b. Okay, so let's assume a equal to 0. Okay, for all integers b. Okay, for all integers b, so we have f0 plus 2 times f of b equal f of b. Okay, so this is valid for all integers b. We also can rewrite this expression as for all x is integers, we'll replace b by x. Okay, with the same thing, because x is an integer, b is an integer as well. So let's put this one on this form now. F of 0 plus 2f of x equal to f of x. Okay, this is true for all x as an integer. So now let's call it first equation. Let's move on to the second term. Let's give a equal to 1 to see what's the new equation for all b is an integer. So we are going to back to the original equation. So we have f of 2 because we are giving number 1 to a. Okay, plus 2f of b equal f1 plus b. Okay, this is valid for all integer b. So now, as you see here, as the second equation, this is second equation. Okay, now we already have the first equation. Let's put it as a number 1. Okay, f of 0 plus 2 times f of x equal to f of x. Okay, so let's plug 1 plus b into the first equation to see what the expression is. Okay, so this one is given as f of 0 plus 2 times f1 plus b, okay, equal f of 1 plus b. Okay, this is the third equation. Okay, as you see here, this is third equation. As you see here, the equation number 2, we have f of 2 plus 2 times f of b equal to f of f1 plus b. And third equation, which is coming from the first expression, from first equation, just to plug in 1 plus b into the first equation is giving us this third equation, which is f of 0 plus 2 times f of 1 plus b equal to f of f1 plus b. Okay, what I can do with these two equations, as you see here, are the same. We have equality of this equation. We have f of 1 plus b. The third equation, we have f of 1 plus b. I can replace the second equation into the third equation. Okay, my goal, I'm going to eliminate f of a1 plus b from this expression. So let's clean up the board and put this to this equation at the top and continue with our problem. Equation, I'm going to combine these two equations into one equation, okay, by simplifying this composition from this expression. Okay, f of 2 plus 2 times f of b equal to f of 0 plus 2 times f of 1 plus b. Okay, so I have this one as a fourth equation. Okay, as a fourth equation. Now this is valid for all integer b. This one it will be valid also for all x as an integer. Okay, so for all x is an integer, for all x is an integer, so we have f of 2 plus 2 times f of x equal to f of 0 plus 2 times f of 1 plus x. Okay, now I'm going to bring x term to one side and the constant terms to the other side. Okay, so this one equivalent f of 2 minus f of 0. I'm bringing f of 0 to this side with f of 2, okay, as a value, as a constant value. So this one become 2 times f of 1 plus x minus f of x. Okay, now I'm going to divide both sides by number 2. Okay, so the new expression become f of 2 minus f of 0 over 2 equal f of 1 plus x minus f of x. Okay, so the term on the right hand side is written as a difference of consecutive terms, and on the left hand side I have these values, f of 2 minus f of 0 over 2 is written as a constant value. Okay, function f of x is an arithmetic progression. Okay, can be written on this form as a linear equation, mx plus p for all m p x are an integers numbers. Okay, now I'm going back to the original equation where I can have substitution, combination this equation of x into the original equation where I can find the terms mp. Okay, this is f of x is a linear equation. Okay, let's verify that. So we have f of x equal to mx plus p. Okay, so let's this expression 1 plus f of 1 plus x minus f of x equal m f 1 plus x plus p minus mx plus p. Okay, this one equal to mx plus m plus p minus mx minus p. Okay, we're going to cancel out p and mx and x. What's left? M. M is a constant, so now we have m in this one. F of 1 plus x minus f of x equal m is a constant equal, which is m f of 2 minus f of 0 over 2. Okay, so I'm just verifying our statement is true. So my equation is a linear equation, so this one. Now I'm going just to replace the first equation into this function to see what's the next equation. Okay, so we have f of 2a plus 2f of b equal to, let's replace this one into this one here. So we have m 2a plus p plus 2 times mb plus p. Okay, this one equals to 2ma plus plus p plus 2mb, okay, plus 2p. This one equal, let's multiply 2m, put 2m as a multiplier. We'll have a plus b plus 3p. Okay, so this is the first, this is just the left side of this first equation. Let's calculate this composition, the right side of this equation. We have f of a plus b to find out numbers m and p by inserting this one into this function as a linear function. So this one is giving us equal m. Let's again replace this one into ax. Okay, f of a plus b, okay, plus p. Also, I'm going to replace this one into this function. I'm calculating f of a plus b now. M is m, okay, a plus b, okay, plus p plus another p here. Okay, this m is multiplied by this one and also with p, but this p is outside of this product. Okay, so we have m squared a plus b, m squared multiplied by a plus b plus mp plus this p. Okay, so let's combine these two equations into one equation, because this one equal to this one, so the same thing equal this one equal to this one. So now my new equation become 2m a plus b, 2m multiplied by a plus b plus 3p equal to this one, m squared a plus b plus mp plus p. Okay, now I'm going to match the left hand side of equation with the right hand side of the equation, like terms. Okay, so we have on the left hand side, if you take a look at here, we have a plus b. On the right hand side we have a plus b as well, and then also plus the term 3p, we have mp plus p. Okay, so this one we can rewrite as you see here. This last equation, we have a plus b on the left hand side, I have a plus b on the right hand side as well. We have 3p, we have m plus 1p, we have p terms on side, I have a plus b on side. I'm going to match like terms. Okay, the left hand side with the right hand side. I will have the equation system now. So as we match these numbers, so a plus b, as we have 2m equal m squared. Okay, the second equation I will have 3p, let's put it this one, 3p equal n plus 1 multiplied by p. Okay, Now I will have two cases here. I have m equal to 0 or m equal to 2, okay? If have m equal to 0 or m equal to 2, okay? So we have m p plus p equals 3p, okay? M equal to 0. That's mean this equation become let's plug in 0 into this expression, so we will have p equal 3p, okay? This is true statement if p equal to 0. There is no another number it can give you this equality. P equal to 3p, only 0. So this one is going to be 0, okay? P equal to 0. What does mean? My equation line, this one f of x equal to mx plus p, I'm doing m equal to 0, okay, and p equal to 0. This now I have one equation, first case. So this one f of x equal to 0 for p equal to 0, okay, for all integer. Okay, this is the first case. Okay, let's bring this one at the top and continue with second case, okay? So if m equal to 2, okay, that's mean my function, this one, number 2, let's replace number 2 here, become 2p plus p equal to 3p, okay? This one equivalent for this case m equal to 2, number 2, so this one 3p equal to 3p. This is true for all p as an integer number, right? Before we found 3p equal to p. This will be true only for p equal to 0. Otherwise, you will be in trouble, okay? So this one, this expression is valid for all p as an integer number. So now my equation become f of x equal to 2x plus p. This is my second equation, okay? The first equation, it was f of x equal to 0, okay? P equal to 0, okay? This is for all x is an integer number, okay? This is the final result. Now I'm going to verify my equation to make sure my statement is true, okay? I'm going to plug these two equations into the original equation to see the statement that I have before as an original equation is true, okay? By using this equation, okay? Let's do the verification now. This equation into this equation. We have f of 2a plus 2f of b equal to 0, okay? Let's hold this one. And then also I have f of a plus b. I'm going to plug into this one, which is so now I'm plugging the second term which is located on the right side of this equation into this equation. F of f a plus b equal to 0, okay? It's always to 0 because whatever x is, okay, then my equation becomes 0. Okay, this one 0, 0. So that's mean 0 equal to 0. So this is correct. This is first case. Second case, this equation, I'm going to plug this equation into this one, okay? I have f of 2a, I have this equation first, for f of x equal to x plus b, okay? So let's mean f of 2a plus f of 2b, f of 2a plus 2f of b. Let's plug this one into here. So this one become 2a plus b, that's 2 times 2b, okay? 2b plus ba plus b plus 4b plus 2a. Okay, so this one is 4a plus 4b plus 3b. Okay, let's calculate the second term on the right hand side of the original equation into this equation. Okay, so f of a plus b, so equal to this one. Let's put 2 f of a plus b plus b equal to times f of a plus, let's plug in this one into here, into x. So this one become 8 2 times 2a plus b. Okay, plus b is the same. Okay, so now my statement is true. Okay, so the only equation that I have, okay, we have f of x equal to 0, p equal to 0. Okay, the second equation, f of x equal to 2x plus p for all integer p. Okay, this is the equation that I have for all x is as an integer number. Okay, this is the good place where I can stop. Thank you for watching. I will see you in next video. Bye.